Hello, hello. I think we are live now. Okay. Let me just check once. Yes, I think we are live. Okay, good. We can start the session now. I hope my voice is clear, right? Okay. So today in this session, we are going to discuss some basic concepts of chemistry. Okay, and we are going to do full chapter. Okay, full chapter. This session is maybe going to be between 1.5 to 2 or 3, max 2.5 hours it can go. Okay, so I want you to sit with some snacks and some notes. Okay, so whatever I am saying, you have to take notes. If you have any doubts, okay, you start asking questions from me. Okay, and there are some in between illustrations as well, so you can understand like how can you apply those concepts. Now if somebody who's live, can you just write your name? Those people who are watching right now live, write your name, guys. People who are watching, write your name, guys. Okay. Okay, so let's start some basic concepts of chemistry. Now, okay, Vinod Kumar, hello, how are you, Vinod Kumar? Okay, good. So we are going to start. Okay, if you guys have any queries, you guys write down it in the comment section. Okay, this live chat, and I will get to know your queries. Okay, so first of all, the first thing that you need to understand is what is a mole. Okay, so let's first understand what is a mole. Okay, can you guys tell me, if somebody is in the comment section, can let me know what is mole? Okay, so see, if you have a mole is like a collection of particles. Okay, a definite number of collection of particle. For an example, okay, if you have any compound, any element, if you have this much number of particles, 6.022 into 10 to the power 23, if you have this much number of particles of any compound, any element, any atom, okay, we have another people as well. Kanishka, good evening, Kanishka. Priya Jyoti, good evening. Okay, Vinod Kumar, your teaching is very good, sir, thank you. Okay, and okay, we are going to start the session, and Vinod, Priya and Kanishka, if you guys have any kind of query, okay, which is like unsolved for this chapter, you let me know. Even if you have some question that, sir, I am not able to solve this question or understand this question, you let me know in the live replay. Okay, I will try my best to answer your queries. Now first of all, let's get clear with the definition of this mole. Okay, what is a mole? See, you have thousands and millions of particles. Now if you pick this much number of particles of maybe any compound, right, any compound, right, maybe any element, okay, maybe any atom, okay, whatever it is, then it is called 1 mole. Okay, then that much number of particle is called 1 mole. Okay, just like if we have bananas, right, if we have bananas and if we have 12 bananas, it is called what? A dozen. What it is called? A dozen of banana. It means there are 12 particles. Okay, I'll not say particle, but 12 number of bananas. Okay, so for it, that number is 12. Same way, 1 mole is this much number of particles of anything. Maybe 1 mole of compound is what? It means in 1 mole of that compound, this much number of particles are there. In 1 mole of that element, this much number of elements are there. In 1 mole of atom, this much number of atoms are there. Now you will get to know what is so special about this particular number. Okay, this particular number, it is so much special that it has been given a separate name for this particular number, and this particular number is, somebody can tell me what it is called? Priya, Jyoti, Kanishka, everybody let me know what is this number called. Okay, let me see your chat as well. Okay, so this number is called what? Avogadro's number. What it is called? Avogadro's number. Now I hope you are clear with what is a mole. You got it? This much number of particles of any compound, element or atom is called a mole. Okay. Now those who are studying for boards or something, let me just tell you the definitions also. Okay. Okay. Now a mole is the amount of substance. Okay. What does mole represent? It represents the amount of substance, okay, that contains as many entities. Entities means like maybe atoms, molecules or other particles, as there are atoms in exactly 12 gram of the carbon. Now the definition is bit off here, okay. See, it is saying the number of particles, the cluster of number of particles, that number of particle is same as the number of particles in this thing, okay. Now the number of particle in this thing is actually what? Na itself, okay. Now the number of particles in 12 gram of 12 isotope carbon is this much, okay. Got it? Understandable? Is there any question, guys? You understood it? Let me see. Okay. Now let's go on. So now we need to determine this number, okay, like how much, like what is this number? In order to determine this number precisely, okay, the mass of a carbon 12 atom was determined by a spectrometer. So first of all, if to get to know this Avogadro number, this Na, okay, we wanted to determine this Na. So what we did, we found out the mass of carbon 12. Why am I saying carbon 12, carbon 12? Because there are other isotopes of carbon as well. Carbon 13, carbon 14 is also there, okay. So these are other types of, in those types of carbon we are taking carbon 12, okay. So what we did, we found out the mass of carbon 12 and we found to be equal to this much grams. Got it? So one of that particle is equal to this much of gram. Now knowing that 1 mole of a carbon weighs 12 gram, the number of atom in its equal is equal to, okay. So knowing that 1 mole of carbon weighs 12 grams, so we know that 1 mole of the carbon is weighing how many grams? 12 grams, okay, and the weight of that carbon 12 is this much. So we can actually divide this number by this number to actually find out the value or the number of particles in that 1 mole. Got it? This is known as the Avogadro's number. Understandable? Now, as said, if you guys have any question, you let me know down in the comment section, okay. Now in a simple way, we just said we can just say that the mole has this much number of entities. Got it? This much number of atoms, molecules or ions. This is what I said. A mole has this much number of particles, maybe of an atom, maybe of a molecule, maybe of a compound. Got it? So now this is one of the most important page. Let me tell you, this is one of the most important page. Why? Because in this important pages there are 3 ways. In this page we are going to learn about 3 ways how we can find out number of moles. Now this way you can solve literally more than like tons of problems of some basic concepts of chemistry, okay. So some of the ways are represented over here to find out how to find number of moles, okay. So let's see. Now our target is to find number of moles. Now you can write this in your notes as well, okay. Let me see if there is any chat or will, okay. If somebody is watching, you guys can let me down, like write down your name, okay, in the live replay. Now okay, so see, we want to find moles, okay, number of moles of a particle. There are first of all 3 ways, okay. Let me write those 3 ways for you. The first and the foremost way is, okay, finding the moles from number of particles. You can find out how many number of moles are there from the number of particles, okay. Got it? So what did I teach you? I taught you that, sir, 1 mole is equal to how many number of particles? Tell me, sir. 6.022 into 10 to the power 23, sir. This much number of particles are there in 1 mole. Okay, right? Now if I ask you, okay, this number is, instead of writing this big number again and again, I am just going to write Na. Okay, Na particles. Is that clear? Understandable? So instead of writing this particular number again and again, I am just going to write this Na. Okay, for this session. Now, okay, now we have 1 mole for this Na number of particles. It means 1 mole is equal to how much? Sir, Na number of particles. Okay. Now, it means, can you tell me for 1 particle, okay, let me write this way, Na number of particle, okay, is equal to 1 mole. Got it? It is clear, right? Now, if I tell you how many number of moles are there, okay, how many number of moles are there in 1 particle? So, in 1 particle, the number of moles are how many? Sir, you divide this is Na is a number, you divide it over here, okay? So, if you divide it, this much number of moles are there in 1 particle. Got it? In 1 particle, this much number of moles are there. Clear? Right? Okay, somebody else is there. Nice. Now, let me tell you, this 1 particle, this much number of moles. Now we have n number of particles. Then how can you find number of moles in them? Okay, it's very good. You just multiply this number with the value n. So if I multiply this for 1 particle in a number of moles. Okay, this much number of moles. So for n particles, got it? This much number of moles is going to be there. Understandable? How you get the formula? Is it clear for you? How do you find out the number of moles from the number of particles? So what is the formula? Can you tell me? The formula, sir, the formula says given number of particles, okay? Given number of particles. So how many particles are given to you actually, okay? Given number of particles upon the Avogadro number or Na. Got it? It is also called as what? Avogadro's number. I hope it is understandable, right? This is the first way, okay? To find out mole, how many number of moles are there by utilizing the number of particles. I hope it is understandable, right? Okay, clear? Okay, now let's see. Okay, now we are going to understand second way of finding number of moles, okay? So, the first way was to find number of moles by using what? Okay, by using the number of particles. Now we are going to understand, sir, how can we find number of moles by utilizing the amount of mass given to us, the mass in grams that is given to us, okay? If somebody else is joining, just let me know. 3 people are watching, okay? You guys write your name, somebody is watching, okay? Now, second way of finding number of moles is what? Tell me. Sir, we can find number of moles by utilizing the amount of weight of a substance given to us, or you can say mass. From where? Mass of substance, okay? We can find number of moles by utilizing the mass of substance, okay? Remember, in 1 mole, okay, what is the weight of 1 mole of substance? Sir, 1 mole of a substance is always equal to the molecular weight, okay? Molecular weight is equal to molecular weight, but in grams. Got it? So 1 mole of anything is equal to the molecular weight in grams. Sir, for an example, say you have hydrogen, okay? 1 mole of hydrogen is going to weight the weight of this substance. What is the weight of hydrogen? There are 2 hydrogen molecules. 1 hydrogen weighs 1 gram, okay? And 2 hydrogen will weigh 2 units, okay? 2 units, but in grams. Got it? So 1 mole is equal to 2 gram for hydrogen only, okay? Can you tell me another example? Tell me for O2. Tell me for O2. How many number of moles are there? Tell me. See, 1 mole of O2 is equal to how much weight? Tell me. 1 mole of O2 is equal to If somebody is watching, just comment down, guys. You guys are watching, okay? Just write your name. It's not a problem. Okay, Vinod Kumar, good evening, okay, good. Now, 1 mole is equal to how much? 1 mole is equal to O2's weight. What is O2's weight? Sir, 32 units, but in grams, okay? So, G. So, this is the weight of 1 mole. Got it? See, but one thing is very common. Now, I will tell you the importance of Avogadro's number. 1 mole of hydrogen was what? What is the weight of 1 mole of hydrogen? Sir, 2 grams. Okay, right? Okay, again, take N2. What is the weight of N2? Sir, 1 mole of N2 is equal to the weight of N2 but in grams. So, weight of N2 is how much? Sir, 28 units but in grams. So, 28 grams. Got it? Now, can you see? 1 mole of this is 28 gram. 1 mole of oxygen is 32 gram. 1 mole of hydrogen is 2 grams. Okay? The weight of 1 mole of the particles are different. But you know the best thing about this, okay, somebody has commented something. Good, 32 gram. Now, the weight of these things are different for their 1 mole. But you will remember what is the importance of the Avogadro number here. In all these amount of substances, the number of particles of N2, the number of particles of O2, the number of particles of H2, they are all same. Okay, all same what? Same number of particles. And what is the amount of that particle? So that is Na. Understandable? So in all of these three things, the number of particle is going to be Na. 6.022 in 10 to the power 23. This much number of atoms in this, this and this. So it doesn't matter whether the weight of this thing is 28, which is high compared to the hydrogen. The number of particles in that thing is same. I hope you understand what is the importance of, okay, somebody has written something, okay. So now do you understand the importance of the Avogadro's number, Na? What is the value of Na? Once again 6.022 into 10 to the power 23. Remember this number, don't forget this. Okay, now let's get back to our topic. I'll erase this. Okay, I hope you note it down. I hope you understand the logic. Okay, if there is any confusion, you let me know down in the chat. Okay, 5 people are watching. Very good. Now, see, mass of substance. Second way of finding mole is mass of substance. So what I said, 1 mole is equal to the molecular weight in grams. Got it? That is the weight. Now, can you tell me? See, I'll take this number to be m. 1 mole is equal to m grams. Okay? Understandable? 1 mole is equal to molecular weight of the substance in grams. Got it? Now, can you tell me how many number of moles? I'll just write it in this way. Okay, this is written this way. I'll write it this way. Just give me a second. I'll write it this way. So, m gram is equal to what? 1 mole. What is the value of m here? It is the value of the molecular weight. Okay, molecular weight of the substance we are talking about. Okay. Now, can you tell me what is the weight? This m is a number. For H2 it is 4, for O2 it is 32, and for nitrogen it is 28, right? It is different for different compounds. Now, can you tell me for 1 gram how many moles are there? Sir, for 1 gram, it is 1 by m number of moles are there. Okay, just like previously we did for the number of particles. Okay, now 1 gram is equal to 1 by m number of moles. Now, tell me, think about this. If I ask you, you have x gram of some particle. You have x gram of particle, 2 gram of some particle, 3 gram of some particle, 5 gram of some compound, 6 gram of some element. If I say this, do you have the answer for 1 gram? Can you get the value for x gram? Yes, sir. We can multiply this both thing by x to get the answer. So x by m. Okay. Now, so x grams of any substance. Remember, x grams of any substance is going to have x by m number of moles, and I hope you have studied this formula a lot and a lot. Got it? If you understood this concept, tell me yes. Write down yes in the comment section if you understood this. Now, this is the traditional formula that you study. What is x? Sir, x is the given mass. 5 gram, 6 gram, 8 gram, 2 kg, 3 kg, whatever the mass of the element, atom or compound is given to us. That is given mass. Okay. Now, again, what is m over here? M is the molecular mass. What it is called? Molecular mass. Okay, molecular mass. Understandable? This was the second way of understanding the or finding number of moles from the mass of substance. So what we did, we are able to find out the mass of substance, okay, from what? Sorry, from mole we can find out from number of particles. We understood about mass of the substance, okay, from mass of the substance you can find out number of moles. Then third, can you name me what is the third way of doing this? Third way of finding the number of moles. Okay, you note it down quickly. Take a screenshot of somebody who is watching the recording. Take a screenshot. Okay. Okay, good. Now let's start. So we studied how to find number of moles from number of particles, from the mass of the substance. Now third way. The third way is finding number of moles from the volume. Sir, volume. Okay, this is a new thing. Okay. Somebody who's watching the chat, guys, please write your name. Okay. Now we are going to understand how to find number of moles if we have given a certain volume. Okay, some volume is given to us like 23 liter, 24 liter, 25 liter, 26 liter, 8 liter, 5 liter, 5 ml, something like this of some gas. Obviously, because volume will only be occupied by some gas, right? We are not talking about volume of a solid. Okay, this thing is valid for a gas. Okay, remember. So third way of finding the mole by using the volume of a gas, because it is very hard to find out the weight of a gas, right? But we know the volume, right? Okay, but remember, okay, how many people are there? 4 people are watching. Okay, good. Now volume of gas, how can we find the number of moles? By utilizing the volume of gas. Okay, this particular scenario that which we are going to discuss right now, it is based on one logic. The logic is that we said, sir, 1 mole occupies n number of particles. First case, we said 1 mole occupies or weighs m. What is the molecular mass of that substance in grams? Got it? And the third logic that we are going to utilize for this is 1 mole, okay, is equal to 22.4 liter. 1 mole, okay, is equal to 22.4 liters. Okay, remember, always, but there is one condition. Always remember, you should use this logic only and only when in the problem they have written that this is at STP. Okay, what is STP? Can you tell me? Anybody who knows what is STP? Anybody who's watching, tell me what is STP. Guys, if somebody is watching, tell me what is STP. What is STP or maybe NTP? You have heard of this in chemistry, right? Sometimes in the problems they will be giving in STP, at STP, at NTP. Something is given, right? Tell me. Okay. Nobody is replying. Why? People are there. You are not replying. Okay. Now. Okay. Now 1 mole is 22.4 liter. Always remember, this thing should only and only be used. This logic should only be used when the system or the gas you are talking about is at STP. What is STP? Sir, STP is known as standard conditions of temperature and pressure. Okay, there is one thing also that is known as NTP. NTP is called what? Normal conditions of temperature and pressure. Got it? This is NTP and this is STP. I think at STP the 1 mole is equal to 22.4. At NTP it is little bit different. Okay, somewhere I think I have heard it is somewhere around 22.7. Okay, now what is difference between NTP and STP? STP is taken as 1 atm, okay, and this thing is taken at 1 bar. because there is a small difference between 1 bar and 1 atm, that is why volume of 1 mole of gas is little bit different in NTP and in STP. Got it? I hope it is understandable, right? Somebody has written something. Standard temperature and pressure. Very good, Kanishka. Very good. Standard temperature pressure. Very good, Priya. Okay. Now this thing is done. Volume of gas. Now tell me how we are going to solve problems. All of the some basic concepts of chemistry problems, mostly and majority of them, they are based on some finding number of moles. Okay. Now see this. So how many ideas we have to find number of moles? Tell me. 3 ideas, right? Yeah, biased approach. Oh, sorry, mark. Good. So, sir, we can find number of moles. Okay. We can find number of moles from what? Sir, we can find it from number of particles. Okay. We can find it from what? From what? The mass of the substance given. Mass of substance. Okay. Okay. Another way is finding from the volume of gas. Okay. By the way, I think I didn't give you the formula from the last slide. Okay. Somebody has written something. NTP is normal temperature and pressure. Very good, Kanishka. Okay. Volume is by how can you find number of moles from volume of gas? Simple formula. Given volume. Okay. And remember, most of the time what people do wrong is they put this particular thing in milliliter. No, this is in liter. Your given volume, you have to convert it into liters and then you have to write the formula. Okay. Divided by 22.4, what? This is liters. Okay. So now this is the formula. Last time I think in the last slide I didn't give this formula. So here is the formula. Got it? Now see how they will be forming questions. What they can do? They'll tell you the volume of substance and they will ask you the number of particles in it. Got it? So you first find out volume of gas. Oh sorry. You can find out volume of gas. Okay. From the given volume you should get the number of moles. Once you get the number of moles you should convert it into number of particles. Okay. Sometimes they will give you the mass of the gas, okay, convert into moles and find the volume of the gas, okay. So every conversion can form from these 3 points, that's it, okay. Mole is nothing else than this. I'll give you just 5 seconds to like note it down, okay. If you understand this concept, type yes in the comment section. If you understand this concept, Kanishka, Priya, Pro Gamer, Vinod Kumar, type yes in the comment section if you understand this concept. I'll change the color also. The white looks good. Oh, white I can't utilize. Okay, let it be. Okay, type yes in the comment section, guys. Now let's go. Okay, on to the next. Okay, I'm just erasing it. I hope you guys have noted down. Now let's see. So as we discussed, okay, you will get this PDF. Don't worry about this PDF. Okay, you should only focus upon studying. Okay, I'll provide you the PDF. Don't worry about this thing. Okay, so first of all, in a simple way, that's it. We studied about Avogadro's constant. Now here are some formula 1, 2 and 3 to find out number of moles. First, number of moles using the weight of the particle, mass of substance, okay, where molar mass is equal to gram atomic mass or gram molecular mass or gram ionic mass, okay. It is just the mass of 1 mole, that's it. That is called gram atomic mass. Now you can find from number of moles also by utilizing the volume. So where V is the volume of gas in liter at NTP or STP, but there is a little difference, do not get confused. Sometimes in the problems you might see 22.7 or 22.4, okay. One of them is at STP and one of them is at NTP, got it, okay. So don't get confused if the values are just little different. 22.4 is not given, sir. Sir, 22.7 is given. Okay, yes sir, Priya Jyoti, yes sir. Okay, thank you. Keep letting me know that you are understanding the concept, and if you have any problem you just let me know, okay. Now number of atoms, okay, Now, again we can easily find number of moles by utilizing what? By utilizing the number of particles, okay? Given number of particles divided by the Avogadro number. Given volume divided by 22.4. Given weight divided by molecular mass, okay? Now, all of these three things are going to convert the or get the number of moles, okay? So, if you get one, you can convert back and then get another. If you get one, convert back and get another. Okay? Now that is it, okay? That's how you find number of moles. I will say 60 to 40 like percent of the problems, they come from this situation, okay? They come from this situation. Now let's move ahead, okay. Okay, some definitions are there, just let's quickly cover these definitions up, okay? First of all, what is atomic mass? Tell me. Atomic mass. Simple definition. What is atomic mass? Okay, atomic mass is the mass of one atom, right? Now see, it is defined as the number which indicates how many times the mass of one atom of an element is heavier than comparison to 112. Okay. There is some very jargon definition is there. Okay, let me tell you. First, understand what is atomic mass unit. Okay, what is atomic mass unit? When you measure some weight, you measure it in terms of kg. When you measure some length, you measure it in terms of meter, right? And if you're measuring very smaller lengths, what do? You measure it in terms of what? Yes, you measure it in terms of centimeter, millimeter. Now, when there are very small number of smaller atom, right? For this, you have to take very small unit. Okay, for that, one smallest unit is developed, and that is called atomic mass unit, represented by AMU. Okay. Now, how can you define this unit? Okay. How can you define? Just like there is a definition for length, there is a definition for the meter, there is a definition for the seconds. Okay. Same way, there should be definition for atomic mass unit, and the definition is, what is atomic mass unit? How can you represent it? It is the quantity. It represents the quantity of mass which is 1/12 the part of one carbon 12 atom. Okay. So whatever the mass of one carbon 12 atom is, you take it and you take 1/12 part. Okay. And that the weight of that 1/12 part is known as one atomic mass unit. I hope it is understandable. It is easy, right? Carbon atom, 1/12 part is known as one atomic mass unit. Okay, got it? Now I have a very smallest unit, right? And always remember that 1/12 part of the mass of one atom. Okay, so what do you write? You write the mass of the carbon atom, which we found out by spectrometer. Okay, and we divide it by 12. Okay, and this is the number we receive, 1.67 in 10 to the power minus 24 grams. Remember this number. This number can convert one atomic mass unit into this. So this is very important. Learn this up. Okay, learn this number. One atomic mass unit is equal to 1.67 10 to the power minus 24 grams. Okay, it is equal to nearly this number. Can you see? Nearly this number. What is this number? This is 1 by Na. Can you see this very smooth relationship between these numbers? Okay, so this is a mass of one unit. So when you say, sir, hydrogen atom is, sir, 2 units. What is this U? This is that U. This is the thing you are talking about. Okay, now if you want this to convert into grams, so you multiply by this number, 2 into this number. Okay, got it? So you can convert this in grams. This is the importance. Okay, so this number is important, this number is important, and obviously this is knowing this is also important. Okay, and what is atomic mass? Relative atomic mass. This is relative atomic mass. So when you write, sir, hydrogen is, sir, 2 units, sir. So this is not the mass, this is relative mass. Okay, somebody has written something. Okay, 2 people are still watching, right? Okay, so this is what? 2 units. It means 2 atomic mass unit. Okay, so what is this atomic mass unit? It is represented with carbon 12, 1/12 part. Okay, it means you are representing the mass in comparison to something else. Understandable? That is why it is called relative atomic mass. Okay, so 2U is what? It is just comparison of the mass of something to the 1/12 part of the carbon 12 atom. Okay, that's it. Now let's go down a little bit. If you are able to understand, every time we clear a page, you let me know if you understand the concept or not. Type yes in the comment section if you do so. Okay. Now let's understand what is gram atomic mass. Okay, gram atomic mass. Let's see. Okay, it's okay. So gram atomic mass, let's just go through the definition once and then I'll make you understand myself. Okay, when numerical value of atomic mass of an element is expressed in grams, then the value becomes the gram atomic mass. Simple. Sir, the volume, sir, the mass of one atom is what? Wait, I'll teach you it this way. Where's my cursor? Okay. It's very simple. See, so if you take one atom of hydrogen, the weight is 2 units. Got it? But you see the number. Now you take this much number of atoms, okay, of hydrogen. Then the weight is what? Can you guess what is the weight? What is the weight of this much number of atoms? Tell me. Priya, Shraddha, Aira, very good. Shraddha, Aira, you are also present. Welcome. Priya, Jyoti, Kanishka, welcome. Okay, tell me, if you have one atom of hydrogen, this is the weight. Then what is the weight of this much number of atoms of hydrogen? Tell me. 4 people are watching. Good, good. Tell me guys, tell me. Is there any lag? Oh yes, there is a lag of like 1 minute of lag is there. Okay, I'll not because somebody who will be watching it recorded, it will be too boring for him. Okay, so see, one atom of hydrogen is 2 units. This much number of particles of hydrogen will weigh 2 grams. See, can you see the similarity? Same way. Can you tell me for another mass? One atom of say oxygen and this much number of atoms of oxygen. Okay, one atom of oxygen is weighing how much? It is weighing 32 units. Okay, got it? But this much number of atoms of oxygen will weigh 32 gram. I hope if any of you guys have some confusion between what is like how can you find mole, what is mole or something like this, the confusion is right clear in front of you. This is the mass of one atom, but if you take this much number of particle, which is known as Na number, okay, if you take this much number of particle, the mass is for 1 mole, see, the mass for 1 mole of any particle is equal to the molecular mass but in grams. This is the definition, this is what it is saying. The mass of 1 mole of any substance, 1 mole of any substance is equal to the molecular mass of the substance, okay, but in grams. Understandable? I hope now you understand what is the definition trying to say, okay. Now I hope you understand. Gram atomic mass is equal to mass of 1 gram atom or is equal to mass of 1 mole atom, okay. 1 gram atom you say, 1 mole atom you say, it is same, okay. So it is just representing the number of atoms. Now gram atomic mass of oxygen is equal to mass of 1 gram atom of oxygen, that is mass of 1 mole of the atom, okay. So 16 by Na into Na, got it? This is what? Mass of 1 particle is equal to into multiply by Na. It means if you multiply all this, you will get mass of 1 mole and that is 16 gram. I hope you are now able to understand this thing, got it? Okay. What is molecular mass or relative molecular mass? I already told you, it is the number which indicates how many times the mass of one molecule, okay, compared to the 1/12th mass of the carbon atom. That's it, okay. Gram molecular mass is what? It was about atoms, it was about molecule, that's it. There is no difference at all, okay. Now, here if you see in gram molecular mass, suppose this is H2SO4. For H2SO4, there are 2 hydrogen in 1 atom of H2SO4. There are 2 hydrogens, okay, 1 sulfur and 4 oxygen atoms. This is the mass, or molecular mass is 98 units. Okay, this is molecular mass, and the gram molecular mass is the mass of n number of atoms. This is mass of one atom or one molecule. Then the mass of n molecule is what? 98 grams, which is equal to molecular mass but in grams. Okay, understandable? Now this is just some easy part. Okay, let's get over it. Okay, there is some illustration. That is the illustration that you need to do. Okay, Priya, Shraddha, are you guys watching right now? Okay, if you are watching, then there is an illustration that you need to solve. Can I just shift this? Okay, yes, I can shift it. Okay, so what is actual mass? The mass of one atom or one molecule of a substance is called actual mass. Okay, there is no comparison at all. You are not comparing with units 32U or 4U, 28U. Okay, you are not comparing. You are getting the actual mass itself. So how do you get actual mass? Sir, hydrogen is having 4U and U is atomic mass unit. So how much is the weight of one atomic mass unit? Sir, 1.67. So 4 into 1.67 in 10 power minus 23. Got it? I think it's 24. Okay, 24 is there, right? Sorry, 24. Got it? So this is the actual mass in grams. Okay, in grams, in kgs. That is actual mass. Understandable? So we say, sir, mass of O2 is the 32 AMU. So 32 AMU, when you convert into grams, that is the actual mass. Understandable? So this is relative atomic mass. This is actual mass. Understandable? Okay, I hope I am clear. If I am clear, write it down. Write yes if I am clear, because there is one illustration that I am going to do. Okay, one problem in the next way. Let me just see, I don't want to reveal the answer. Okay, so solution is there. I hope you guys can see this problem, right? Calculate the volume and mass of 0.2 mole of O3 at STP. Guys, do it. I'll set a timer for this. Guys, write illustration 1. Okay, Priya, okay, Kanishka, okay, Shraddha. Right? Guys, write the answer for this problem. I hope you are able to see this. Let me see. Yes, you are able to see this. I can see. Try to write the solution, guys. It's a very simple problem. Calculate the volume and mass of 0.2 mole of O3 at STP. Calculate the volume and mass of 0.2 mole of O3 at STP. 31 seconds are there. Shraddha, Kanishka, Priya. Try to do, everybody. Calculate the volume and mass. You have to calculate volume and you have to calculate mass of 0.2 mole of O3 at STP. Ozone. O3 is ozone, right? You must know the names also. (32) okay. Let's see if somebody has given answer. Okay, I'll try answering. There's a 30-second gap between what I am saying and in the live. Okay. Okay, let's answer now. Okay, so calculate the volume and mass. See, we just need to calculate what? We just need to calculate the number of moles, that's it. So, to calculate the volume, okay, what do? You have 0.2. 1 mole is equal to what? 22.4 liter. Then how much 0.2 mole is equal to? Multiply by 0.2. Multiply by 0.2, that's it, simple. So, you multiply, there is a 22.4 liter. 1 mole is equal to 22.4 liter. So, 0.2 mole is equal to 22.4 into 0.2. That is 4.48 liters. Understandable? Simple. Now, to find, is there anybody who has answered? No, not now. Okay. And how do you calculate mass? So, 1 mole is equal to 48 gram, then it means 0.2 mole is equal to 48 into 0.2. Got it? That's it, 9.6 gram. Now try to do this problem. Find out moles and mass in 1.12 liter of ozone. Let me just zoom this out for you. This is the problem, guys. I'll give you a timer, 1 minute. I'll take. Find out moles and mass in 1.12 liter of ozone at STP. 1.12 liters of ozone at STP. Are you guys watching or not? Hey guys, are you watching or not? Type yes in the comment section if you are. I'm seeing people but I'm not seeing any answers. Guys, 28 seconds. Okay, Priya Jyoti has answered 9.6 gram. Just let me see. Okay. I should just open the chats. Okay, I think. So, Priya Jyoti, you have answered 9.6 gram. I think you have answered for the previous question. Okay. So, then let's get to know about the solution of this question. Now, see, find out the moles in 1.12 liter of ozone at STP. So, you have to first find number of moles. How do you find number of moles? Sir, given volume upon molar volume, that's it. First answer is moles, that's it, it's very easy. Given volume upon molar volume, that is 0.05 mole of ozone. It's very easy. Now, how do you find out mass? So, what do you do? Sir, mass of 1 mole is equal to molecular weight. Sir, what is the molecular weight of ozone? That is 48 grams. Then, for for this much number of moles, what is the weight? Sir, 1 mole is 48 gram. Then 0.05 mole is equal to what? 0.05 into 48. Understandable? That's it. So this is the answer. Okay. 1.12 liter by 22.4 mole. Very good, Priya Jyoti. Your answer is right. Very good. Okay. These were some easy problems. Okay. These problems are not like for competitive practice. Okay. These are for just understanding the concept. Okay. Find out the molecules. Guys, find out the mass of 10 to the power 20 molecules of Cu, copper. For copper, try to answer it. Priya Jyoti, answer it. The timer has started. 10 to the power 21 molecules of copper. You have to find mass. So first you have to find moles and then you have to go through mass. So find number of moles and then number of what is the amount of mass. Okay, do it, guys. Okay, guys, do it. Find out the mass of 10 to the power 21 molecules of copper. 20 seconds are left there. Okay, done. I think we are done. The questions is very easy. I told you first find number of moles and then see, find out the mass of 10 to the power 21 molecules. Okay. Okay. 10 to the power 21 molecules. First of all, find number of moles using given number of particles upon Na. That's what I said. Number of particles, mass and volume can help you find number of moles. So this is how you find number of moles and you get number of moles. Got it? And remember, whatever the value that you are getting, okay, this is the number of moles. Okay, if you divide this number, you will get moles. So mole is equal to given mass upon atomic weight. Okay, so given mass upon molecular mass. because it's not a molecule. Copper is not a molecule. Okay, it's a atom. Okay, so you divide given mass upon 63.5. Okay, then you multiply this number by that side, so you'll get the weight of copper in this much number of molecules. Okay, for this number of particles, this much number is the weight. Understandable? So this is how you find out. Now again, okay guys, do this problem. Half gram molecule of oxygen. Okay, find mass, number of molecules, volume velocity. Okay, and number of oxygen atoms. So you have to find all, like the mass, the number of molecules, volume, and the number of oxygen atoms. That's it. Try to find, guys. Okay, somebody has answered 0.106, 0.106. Okay, Priya Jyoti, you answered first. Shraddha, you answered second time. Kanishka, you answered third. Very good. Okay guys, answer, just 20 seconds are left. Number of oxygen atoms. Okay, 10, 9, 8, 7, 6. Okay, done. Three, 2, 1, 0, done. Okay, now let's see. Okay. So first, what do you need to find? There are half gram molecule, it means the number of moles is half. Okay, so you have to first convert given mass upon molecular weight. That's it. You will get the weight. Understandable? That weight is 16 gram. Okay, because 1 mole is 32 gram, half mole will be 16 gram. That's it. In 1 mole there is Na number of particles, in half mole there are Na by 2 number of particles. Okay, in 1 mole there is 22.4 liter, in half mole there is 11.2 liter. That's it. It's very easy. Okay, and 1 molecule of oxygen contains 2 oxygen atoms. Okay, 1 molecule of oxygen contains 2 oxygen atoms. So if this is the number of oxygen atoms, got it? Then oxygen molecule, then the oxygen atom will be twice that of it. So 2 into Na by 2, that is Na itself. Understandable? This way the question was way too easy. Okay, now let's go on, read our further concept. Okay, so now let's understand about vapor density. Okay, what is somebody has written something, Shraddha. Okay, good, somebody has answered. I can see 0 views, but still people are answering, like how? Let me just check. Okay, so Shraddha Ira said, sir, mass is 16 grams, very good. Number of molecules is, sir, 2 Na, I think not 2 Na, it should be Na by 2. And volume at STP is 4.48 liters. No, volume at STP is 11.2. For what question, I think? And number of oxygen atoms, okay, it's good. Now Priya Jyoti, 16 gram, good. Number of molecule is 2 Na. 2 Na should not be the answer. Na by 2 should be the answer. Volume at STP 4.48. Mass 16 gram, number of molecules 2 Na. Wait, who is which question are you guys answering? Everybody is writing 2 Na. This half gram molecule, okay guys, half gram molecule, not 2 gram molecules. So in 1 gram molecule, Na number of particles are there. So in half moles, 1 mole, Na particles, half moles, half Na particles, got it? Okay, now at STP 4.48 liter, at STP 4.48 liters, for 1 mole 22.4 liter is the mass, for half mole it will be 11.2. Is there any confusion, guys? Are you able to understand this? Why you guys are answering 4.48? See, it is half mole for 22.4 liter, right? 1 mole is 22.4 liter. Half mole will obviously be 11.2. Okay, half of the actual volume. There is some confusion, guys. Watch it out. Okay. Now let's move ahead. Okay, so here we have another concept in front of you. Relationship between molecular weight and the vapor density. First of all, you need to understand what is the molecular weight itself. Okay, what is molecular weight, or what is vapor density? So vapor density, see, you have absolute density, where you know what is gram per centimeter cube, right? In fluid dynamics or fluid mechanics, you must have heard what do you call it? I am not able to recognize or recall that name. Okay, but you say 16 like in terms of water in comparison to water, 50 in comparison to water, got it? 13.7 the mass of mercury comparison to water, you are comparing it to some quantity, right? Okay, so now vapor density is called what? Same way it is a comparison type density, okay, it is not absolute, this is relative density. So vapor density of a gas is the ratio of densities of gas, and the comparison thing is hydrogen atom at the same temperature and pressure. So whatever the ratio of whatever the hydrogen's pressure is, density is at particular temperature and pressure, and the volume of that substance, you just divide it. You are comparing how many times that hydrogen's density. Okay, so vapor density is equal to density of gas upon density of hydrogen. So d gas by dH2. That's it. So this is how you find the formula. This is the definition. Okay. Now we are concerned with the relationship between molecular weight and the vapor density. Got it? See again. Okay, if n number of molecules are present in the given volume of a gas, so in n number of molecules are present and hydrogen under the similar conditions. So similar conditions are there, okay, same condition. So for there are same moles, remember, in same condition, the volume occupied by 1 mole of every gas is same. It may not be 22.4, but it will be same, okay. It is 22.4 at STP only, got it? Now, okay, so see at that point vapor density is equal to what? The mass of the gas of n molecules and mass of hydrogen of n molecules, got it? So now see, m is the gas of n molecules and mass of n molecules of the hydrogen, okay. See, now you can convert number of particles into mass, okay, and then it will be mass of gas of one molecule and mass of gas of one molecule, okay, because the number of molecules are to be same. Now if you compare the mass of gas with the mass of hydrogen, okay, hydrogen has a mass of 2 and the mass of that gas will be somewhat molecular mass, okay, that is m by 2. Hence this is the reason we have the concept over here. Now you take the 2 on that side and you will get this formula. Molecular mass of gas is 2 times the vapor density, always remember, got it? And this is the formula. And for the gram molecular mass at NTP, the volume of 1 mole of a gaseous substance is 22.4 liter, is called the gram molecular volume, okay. 1 mole volume is 22.4, that is called gram molecular volume. That's it, okay. This is just a lot of definitions in there, don't worry about this. Okay, now let's do this question. I hope you guys can see the question, right? If you don't see the question, I'll read it to you. Calculate number of atoms in chlorine in 2.08 gram of BaCl2. Atomic weight is given. Ba is 137, chlorine is 35.5. Guys, try to answer it. I'll give you a little bit more time, okay. So first you need to find BaCl2, okay, just 10 seconds extra. I'll open my chat over here so I don't have to open my mobile every time. Guys, try to answer. Kanishka, Priya Jyoti, Shraddha Aira. Answer it, guys. Guys, try to answer. Okay guys, time's up. 8, 7, 6, 5, 4, 3, 2, 1. Okay, somebody has answered. Shraddha Aira, very good. Okay, So let's see, where is my cursor? Okay. Okay, calculate number of atoms of chlorine in 2.08 gram. So first of all, see, whenever you want to do something, remember always to go with the number of moles. So we have to calculate number of atoms. I do not care. Okay, first of all, this is the BaCl2, 2.08 gram of BaCl2. If you add this number 137, 35.5, you will get what? 208, right? And you have 2.08 grams. So given mass upon molar mass will tell you how many number of moles of this particle you have. You have 0.0 number of 1 mole of BaCl2 and you convert it into number of particles. Okay, so when you convert it into number of particles, suppose you get n number of particles, then in one particle of this there are 2 chlorine atoms. So n number of particles, there will be 2n number of chlorine atoms. Got it? That's it. It is as simple as that. So you can see 0.01 Na, then obviously in one BaCl2 there are 2 chlorine atoms, so you multiply by 2 and you get your answer as this thing. Understandable? Okay, 2 into 10 to the power minus 1, very good. Oh wait, Priya Jyoti, it is 2 into 10 to the power minus 2, okay? And Kanishka, there is something wrong, you are writing 2 into 10 to the power minus 7, which is little wrong, okay? Try to answer, guys. Next question is, can you see the next question? Let me just check. Calculate the number of molecules and number of atoms. So next question is, calculate number of molecules and number of atoms present in 1.2 gram of ozone. 1.2 gram of ozone, guys. Calculate molecules and number of atoms. 1.2 gram ozones. Shraddha, Aira, Jyoti, Kanishka, guys, try to do it. Try to do it, guys. Don't worry, Kanishka, don't worry. It can be wrong sometimes, but it's okay, okay? Just try your best in the next question. Okay, 35, 33, guys. Do it. Number of molecules and number of atoms in 1.2 gram of ozone. 1.2 gram ozone, guys. Calculate number of molecules and number of atoms present in 1.2 gram of ozone. Let me have some water till then. Okay, you guys try to answer. Oh. Okay, just give me a second. Okay, let's start and let's see if somebody has answered or not. Okay, not yet. Anyways, let's start. Okay. So now calculate the number of molecules and number of atoms in 1.2 gram. First of all, find number of moles. Once you have number of moles, you can find number of molecules. Okay, and each molecule will have 3 atoms of oxygen. So you multiply by the number of molecules by 3. That's it. Okay. So first, number of moles 1 by 40. Number of molecules Na by 40. Number of O3 molecules is 3 atoms, it means Na by 40 into 3, so it is 3 Na by 40. That's it. Somebody has answered or not? Okay, I can see in 1.2 gram of ozone, Shraddha Aira has answered 1.2 gram of ozone. There are 401 molecules of ozone molecules and 1203 Na molecules. I think, okay, Priya, this is not 40 into 3 into Na, this is 3 Na by 40, okay? You are multiplying all these numbers, 3 into Na into 40, got it? It is 3 Na by 40, remember this. Now let's see, another question, guys. Another question, guys, the question is at NTP, the density of gas is this. This is the density and this is absolute density, gram per milliliter, absolute density, okay? Find out its vapor density and molecular mass. How can you find out vapor density and molecular mass by utilizing this? Tell me. How? Okay, 43 Na. Okay, Shraddha and Priya, try to answer in the next question, okay? At NTP the density of gas is 0.00445. Then find out the vapor density and molecular mass. Vapor density and molecular mass, guys. Vapor density and molecular mass, how can you find it from this particular density? It is 0.00445 gram per milliliter. It is little good question, just little good, okay? Try to do it. And somebody who's watching the recording, you guys also try to do it. Okay, done. I'll check if somebody has answered or not. Okay, remember. So, vapor density is called what? Density of gas upon density of hydrogen. Now, there is one thing you should remember. This is the density of the hydrogen, okay? It is 0.00009 gram per milliliter, okay? Or you can say 0.000, instead of 9 it is 89, okay? Rounding off you will get 9. So remember this thing, this was important. Remember the density of the hydrogen, okay? At NTP or what you call it, STP. Remember it, 0.0009 gram per milliliter. So finding this, you will get from this, by dividing the hydrogen's density, you will get vapor density. And we know if you multiply vapor density by 2, you will get molecular weight. Got it? So molecular weight is what? 100. Vapor density was 50. So molecular weight is 100. Got it? It is about the relation that we studied earlier. Somebody has answered or not? Okay, Priya Jyoti has answered something. 99.68 gram per mole. Okay, very good. You are very near. And I think you have directly calculated it. It's a very good answer. Okay. Priya Jyoti, your answer is also good. Okay. You have directly calculated it. Very good. So, okay, good. So, you might have taken like for 1 milliliter, this much is the gram weight. So, you found out the value for this for 22.4 liter. So, you got out by multiplying the number of milliliters. I think this is the way you did it. And by the way, it's a very creative and good way. Again, weight of 1 liter gas is 2 gram. So, 1 liter of the gas is weighing 2 gram. Then find out its vapor density and molecular mass. Guys, try to do it quick. Tell me, guys. Priya Jyoti, very good for the next session. Oh, sorry, the previous question, very good. Try to do this question, Priya. Weight of 1 liter gas is 2 gram. Then find out the vapor density and molecular mass. Tell me. Where is Shraddha? Where is Kanishka? You guys are not answering. Try to answer. Shraddha, answer the question. Kanishka. Guys, try to answer the question. Answer the question. What is the weight of 1 liter of gas? Is 2 gram. Find out vapor density. And molecular mass also. See, you had 1 liter is 2 gram. Find the weight of 22.4 liter. Simple. Okay. Then we will have the weight of 1 mass. Atom automatically resize. Okay. Now, this is just quick revision here. Okay. Now, weight of 1 liter of the gas is 2 gram. So, just find out the weight of 22.4 liter. That's it. Okay. So, 22.4 into 2, that is a weight of 44.8. Okay. Now, okay, they have used some other way or not? Okay, okay. So, weight of 1 liter. Find out its molecular mass. So, molecular mass you can easily find out. See, I am utilizing what Jyoti did earlier, I am doing it right now. Or you can do it this way, density of gas is mass upon volume. So, mass is 2 by 1000, that is 0.02 gram per milliliter. So, you found out density, then you find out vapor density. By dividing again, you require this particular information to solve the question this way. Okay. Otherwise, you know 1 liter is 2 gram, 22.4 liter is 44.8 gram, that is molecular mass. And molecular mass, if you divide it by 2, you will get vapor density. Got it? So easy. Now, I hope everybody has answered, right? 44.8. Very good Kanishka, very good Priya Jyoti, very good Kanishka, and very good Priya Jyoti. Okay. Yeah. Now there are some key points we should revise quickly. Okay. First, term molar mass means mass of 1 mole of particle. Okay. Remember, molar mass, gram molecular mass, these number of things will represent or are related to 1 mole. Okay. Vapor density is calculated with respect to hydrogen gas under similar conditions of temperature and pressure. Okay. See, it is not saying STP or NTP. Remember, it is saying similar conditions. It means the gas and the hydrogen, they should be at the similar condition, same condition. Okay. So vapor density is calculated with respect to hydrogen gas. It means it is not absolute density, it is relative density. So relative density is equal to what? Okay, as I told you, vapor density is relative density. And what is relative density? It is density of gas A compared to gas B. That is it. Okay. And this is the thing I was referring to. Specific gravity. In fluid mechanics you have heard the specific gravity of this thing is 12. The specific gravity of this thing is 2. It means it is twice the density of water. It means 12 times the density of water. It is compared to water. Okay. It is density of the material with respect to water. Okay. Here it is with respect to hydrogen. That is what I was trying to refer, specific gravity. Now, again, okay. Now, vapor density or relative density or specific gravity are ratios. So they are unitless. Always remember, they are a kind of ratio. So this is density, this is density. If you divide density by density, what do you get? Obviously, you will be getting something which will have no units. So it is unitless. Remember, the term STP means 27.13 Kelvin, it means 0 degrees Celsius and 1 bar pressure. Okay, sorry, I did one thing wrong. At STP I told you 1 atm, no, it's not 1 atm, it is 1 bar, okay, and 0 degrees Celsius. And NTP is what? It is 1 atm and 0 degrees Celsius. Got it? Remember this thing. NTP means 27.13 Kelvin and 1 atm. See, that's what I was trying to refer. Okay, one of them is 22.4 liter. One of them is 22.7 liters, okay, for 1 mole of any gas. Okay, so do not get confused if you see 22.4 or 22.7. Don't get confused. Okay. Now, okay, let's see. Okay. Okay. So first of all, now we have percentage composition questions. Okay. Now see, if you talk about carbon, carbon doesn't exist in one single form. It exists in carbon 12, carbon 13, carbon 14. Okay. Same way, we have hydrogen. Hydrogen doesn't exist in one form. It exists in hydrogen, deuterium and tritium. And the amount of substance, they like amount which they are found in, okay, the percentage of composition they are found in nature is different. It means the normal hydrogen is found with a very large quantity. Deuterium is lesser, and then tritium is radioactive, and it is found very lesser number of times, okay, very less amount. So we cannot just say that, okay, if carbon, there are 3 carbon, carbon 12, carbon 13 and carbon 14. You can't just say, sir, the mass of carbon is 12 depending upon only this isotope, right? You can't say this, okay, because if you pick some sample of carbon, there will be carbon 12 in it, there will be carbon 13 in it, and there will be carbon 14 in it. If you try to calculate using the carbon 12 method, okay, using the mass of carbon 12, your assumptions will be wrong. Got it? So what do? Actually, we utilize the percentage composition. Okay. Now there is empirical molecular formula. I'll tell you later. Okay. Now we utilize percentage composition to find out what is the average weight. Okay. Average molecular mass, or to be very precise, you can call it average weighted molecular mass. Okay. So let me just give you a touch about it. See, there is a compound C, okay, and there are 2 forms of compounds, Ca and Cb. Okay. In nature, the mass of this is 40 and the mass of this is 41. Okay, but it is found 75% of the times. It is 75% composition and it is 25% composition in the whole nature. So what you will tell if somebody asks you what is the mass of this this molecule or this atom or compound? You will say 40 or 41. No, you will not say none of them. You should say an average, weighted average. So because 40 is present 75 times and 41 is present 25 times, okay, divided by 100. So this is the mass of carbon, the average molecular mass that should be written. I hope now you understand. Or you can write it in ratios. So for example, 40, 75% is written as 0.75, okay, plus 41 into written 25 is written as 0.25. I think you should do it this way, this is better, okay. Both are same thing, you divide 100 with 75, 100 with 25, it is going to be same itself, got it? I hope I am understandable, right? Okay, now let's understand about the empirical formula and then we are going to understand about the molecular formula, okay. What is empirical formula? See, you have C4H4O2, C2S6, CH4, H2O2. You just, if there are some multiple atoms, you are going to represent the whole compound in a simple whole number ratio of the atoms present in it. So, if there are in a peroxide, 2 hydrogen, 2 oxygen are there. So, instead of writing 2 hydrogen, 2 peroxygen, you are going to cancel out the ratio and you write it as 1:1. It means H and O. Again, for CH4, the ratio is 1:4. So, if you try to cancel out ratio, it will still be 1:4. So, the empirical formula remains same. For C2S6, ratio is 2:6. You cancel out, it is 1:3 and you can write it CH3. Got it? Same for this compound. 242, the ratio is 1:1. Then you can write it CH2O. Understandable? So, a simple whole number ratio of the compounds present in it. That's the way you find out empirical formula. Okay? And molecular formula is just the normal formula that you study, okay? CO2, H2, SO4, all these formulas are the molecular formulas because you know exactly how many number of atoms are present in there and not relative number. This is relative number. It means compared to carbon, hydrogen is 4 times. Compared to carbon, hydrogen is 2 times. Okay, compared to carbon, hydrogen is 3 times. But you don't know which compound is it. But you know the relative composition. Got it? Molecular formula is of a compound represent actual number of atoms which are present in it. Understandable? Okay, so here is one of the I'll say most important part of a chapter, okay? Because most of the time the questions are going to form from this boards, NEET, JEE sometimes, okay? See, relationship between empirical and molecular formula. So you are dividing it with the ratio, na? So molecular formula is always some number into the empirical formula, okay? For an example, it was C6H12O6, molecular formula, empirical formula is CH2O. So how many times should I multiply this? By 6, right? By 6 to get this thing. So this is molecular formula, empirical formula and that number, that is 6, okay? That number, understandable? N can be some natural number 1, 2, 3, 4, okay? So N is equal to molecular formula divided by empirical formula, or you can say either not just molecular formula or empirical formula, you can say N equal to molecular formula mass and empirical formula mass, okay? The mass of this thing is something else, the mass of this thing is 180, okay? And this thing is around, you can say 12, see, this is oxygen, right? So oxygen is how much? 16 and this 12, it will something, okay? I don't know. It's, I think 36, right? 36, no, not 36. Whatever it is, just you can find it out later, okay? So whatever CH2's mass, okay? So the ratio, you can also take out the ratio of their empirical formula mass and the molecular formula's mass. Got it? You can also write out. Now, the type of questions that you are going to receive, okay? So again, we are going to provide you some illustrations. The type of problems you are going to receive is that you will receive in some compound, this much carbon is existing, hydrogen is existing, oxygen is existing. And these are the compositions of the carbon, hydrogen and oxygen in that compound. You have to find out the empirical or the molecular formula, okay? That is what you have to do. And this is the process to find out that thing. So, first process is, first of all, find the percentage by weight of each element present in 1 mole of the compound. Okay, so percentage by weight, it means with what weight percentage that compound is formed, present in the compound. For an example, sir, hydrogen is present by weight, it is present at 4%. By weight carbon is 46%. By weight oxygen is 54%. Like this you have to find out. Okay, then the percentage by weight of each element is divided by its atomic weight. Okay, so now you are divide, for an example, if carbon is present 12, okay, 12%, now you divide it with the atomic weight. Got it? Now it gives atomic ratio of elements present in the compound. So it gives you atomic ratio. Okay, how many number of atoms ratio are there? Okay, if you see properly, when you divide 12 with 12, this is representing somewhere mass, this is representing molecular mass, so this whole thing is representing moles, so moles represent number of particles. Okay, so indirectly you are trying to find number of particles, okay, relative number of particles, not exact, okay, because it is a percent, not a perfect number, that's why you will get some number which is some relative thing. Okay, now you got the thing. Now this atomic ratio of each element is divided by the minimum value. Sir, why minimum value? Suppose it is 1.44, another is 1, another is 1.33. Okay, wait, I'll say 1.33, 1.33 and 1.66. Okay, now the smallest number in these ratios are this thing, so you divide by this number, divide by this number, divide by this number. Okay, why? So that these ratios can be converted into simple ratios, okay, to get simplest ratio of the atoms. Now fourth step, if the value of simplest atomic ratio is fractional, then raise the value to the nearest whole number. Okay, look, once you get the ratio, do anything to convert it into simple whole number ratio. Okay, and you know you can do it easily. Now after you find out relative number of compound, multiply with the suitable coefficient to convert it into nearest whole number. Okay, now you can write the empirical formula as we get the simplest number of ratios. So if you have carbon, hydrogen, oxygen is there, right? Carbon, hydrogen and oxygen is there, and the simple whole number ratio is this, it means the empirical formula is CH2O. That's it. Okay, this is the step. Now I think if you understand the concept, okay, I think you can do a problem. Okay, so first of all, I'll give you a timer. In glucose, C6H12O6 is there. What is the percentage of carbon, percentage of hydrogen, percentage of oxygen? Tell me. In glucose, carbon, hydrogen, oxygen is there. What is the percentage composition of each element in glucose? C6H12O6. Tell me, guys. Priya, Kanishka, now. Again, get back to questions, guys. Find out percentage composition of each element, like total weight and the weight of that substance or the atom in that compound. Guys, try to find out. Okay. See, the carbon is present. Carbon is present 6 times. 6 atoms are there. Each atom is weighing 12. So this is the total weight of the carbon. Okay, 12 into 6 divided by total weight of the compound, 180. Same way for hydrogen. Okay, 12 hydrogens are there, and each hydrogen is weighing 1 gram or 1 unit. Okay, divided by 180, the total mass of the unit. Okay, same way for this, and once you divide, multiply by 100 to get the percentages. Okay, mass of that compound upon total number, total amount of the compound. Okay, so somebody is saying what, 44. Okay, 44 some. Okay, Kanishka has written something, but she retracted the message. I was not able to read. Okay. Now the realist question, guys. whatever you have learned in this step, okay, determination of empirical formula, try to do this in here, okay. So I'll just say it. In a compound, carbon is this. Okay, let me just teach you because it will take a lot of time and there's no point I give you some time for doing this, okay. See, you have in a compound, carbon is this much, hydrogen is this much, oxygen is this much are present, and molecular mass of the compound is 92. So you are given with the molecular mass, okay. If you are not given with molecular mass, you cannot find out molecular formula, okay. You can only find out empirical formula from this 3 data, but if you want to find molecular mass, this data is needed. Now carbon is this much percentage, hydrogen this much, and oxygen this much. So you divide it with the atomic weight. Atomic weight is 12, 1 and 16. So 52.2 divided by 12, 13 by 1, 34.8 by 16. Once you divide, this is the ratio you get, okay. Now if you want to divide this ratio, now which one is the smallest ratio? So 2.2 is the smallest one. So divide every number with this ratio. So 2.2 by this, 13 by this, 13 by this. So you get 2, 6, 1. It means carbon is 2, hydrogen is 6 and oxygen is 1, okay. Now find out the empirical formula mass. Sir, empirical formula is this and the mass of this formula is 46, but the mass of the compound is 92, which is double, right? It means if it is double, it means the value of N is actually 2, got it? So the number of particles are twice which are in the empirical formula, so just double it. So C4H12, okay, and O2, that is the answer, okay. And these are type of questions are very easy, and especially they sometimes come in boards or some easy exams, okay. The less answer that you will see in your NEET because they are time eating questions, okay. Now let's study our stoichiometry, okay. It's very easy. One of the most important aspect is the chemical equation is that when it is written in a balanced form, it gives quantitative relationship between the various reactants and the products in terms of, okay, leave it. So whenever you write any equation when it is balanced, okay, so whatever the number is in front of it, 1, 2, 1, 1, it tells you the quantitative relationship, okay. It means 1 mole of this can combine with 2 mole of this to form 1 mole of this and 1 mole of this, got it? Now if they give you this much weight is required for calcium carbonate, then how many mole of HCl is required to react with? So you know 1 mole of calcium carbonate requires 2 HCl to react, got it? So you can easily find out what is the weight of HCl that is required, okay, understand. And not just moles, you can see it in terms of volume also, okay. So 1 unit volume combines with 2 unit volume of this substance to find out this, okay. But remember, volume is for something only when it is a gas, okay. Calcium carbonate is a solid, so volume will not be considered in here, right? Okay, so it means 1 mole of the calcium carbonate reacts with 2 mole of hydrochloric acid to give 1 mole of calcium chloride and 1 mole of water and 1 mole of carbon dioxide. Remember this, okay. So they can ask you different question like what will happen if 0.5 react with 1 mole of this thing, like this, okay. Now if you convert this 1 mole, okay, what is the weight of 1 mole of this calcium carbonate? It is 100 gram. It means 100 gram of calcium carbonate react with 73 gram of HCl to form 111 gram calcium chloride and 18 gram water and 44 gram of carbon dioxide, got it? Okay. Now okay, I think I have same way this problem is also done here, okay. This problem was in terms of weight, okay. Where's my mouse? Now this problem, this particular example is in terms of volume, when volume is using, okay. Somebody has answered something, okay, 53.33, Priya Jyoti, very good, Kanishka, very good, okay. I didn't saw your answer guys, sorry, okay. So see, if you are given with in terms of gas, okay, see, even if it's a mole or even if it's a volume, it's all the same thing, okay. So N2 reacts with hydrogen to form ammonia. So 1 mole of nitrogen, 3 mole of hydrogen is equal to 2 moles of ammonia. So you can say 1 liter of nitrogen, 3 liters of hydrogen and 2 liters of ammonia is there, right? Same way you can just convert all the ratios, okay, 1 milliliter, 3 milliliters, 2 milliliter, okay. So you can convert in terms of weight also. 28 gram of ammonia, nitrogen reacts with 6 gram of hydrogen to form 34 gram, what do you call it, ammonia. Understandable? According to the law of conservation of mass. Remember, law of conservation of mass is also applied. If this reacts with this, obviously this will form, and 28 plus 6 should be equal to 34 according to law of conservation of mass. Get it? Okay. Now, gram cannot be represented according to stoichiometry. Okay. Remember, the quantity, see, we cannot represent this gram in terms of stoichiometry. Just because the ratio is 1, 3 and 2, it doesn't mean that 1 gram, 3 gram and 2 gram are going to react like this. No, gram cannot be represented according to stoichiometry, but moles and volume can be represented. Remember this. The quantitative information conveyed by a chemical equation helps in the number of calculations, the problems in one. Okay. See, there are different types of problems that can be there in case of these things. Okay. So first type of problems are single reactant based. So single reactant is there which is like reacting. Now see, it can be mass to mass relationships can be there. Mass of one of the reactants or the product is given, and the mass of other reactant or products they can ask, right? Another type of problem, mass and volume. So what they do is, mass or volume of one of the reactant is given or product is given, and the mass and the volume of one of the other reactant is to be calculated. Okay, and volume problems. So they will give volume of one thing, you have to find the volume of the other by using what? By using stoichiometry. Okay, whatever the stoichiometric ratio is, okay, 1, 3 and 2, that is you have to consider, and I think everybody of you somewhat know this thing. Okay. For balancing the combustion reaction, first of all balance the carbon atoms, then balance hydrogen atoms. Remember always, if you want to balance the combustion reaction, first you have to balance the carbon atoms, then balance hydrogen, and finally balance oxygen atoms. Okay, remember this thing. Finally, first balancing the carbon atoms, 2 here, 2 here, so 2 multiply. Then balance hydrogen atoms. How many? 6 here, 2 here, so multiply by 3. Then balance oxygen atoms. So it is, then oxygen is here, how much? 3. Okay, and 2 something, so it is divided by 7, 2, it means 7 oxygen atoms. Okay, got it? So we studied mass, volume. So first of all, do this problem. First type of illustration is there. Type 1, how much iron can be theoretically obtained in reduction of 1 kg of Fe2O3? Okay, so I will tell you reduction of Fe2O3. So this is the formula. Okay, if you guys might not know the formula, here is the. So first type of illustration, reduction of Fe2, 1 kg of Fe2O3 is there. Okay, so it is asking how much iron you will get. It means weight of iron. Nobody is going to deal with the moles of iron. Okay, weight, you have to find weight by reduction of this. So Fe2O3 is there. When it reacts with hydrogen, you get iron and water. Okay, this is reduction reaction. Okay, reduction means oxygen is getting removed. Now if you balance this reaction, this is in ratio of 1, 3, 2 and 3. Got it? It means if 1 mole of this is reducing, 2 mole of iron is getting formed. Okay, so how many number of Fe2O3 we have? We have 1 kg. Okay, so 1 kg given mass, that is 1000 gram, divided by molar mass, you will get number of moles. Okay, and once you get number of moles, okay, twice the number of moles you will get for iron. Okay, so into 2, this is the number of moles, into 2 is the number of moles of iron that you will get. Okay, the equation shows that 2 mole of iron are obtained from 1 mole of ferric oxide, obviously. So number of mole is what? 2 into this particular number. So you get 12.5 mole, and for 1 mole of the iron, what is the weight? 56. Okay, so for 12.5 mole, 700 gram. Got it? So you went into from, see, you went from weight to moles, then moles to this thing, then moles to again weight. Understandable? That's what you did. Weight of Fe2O3 to moles of Fe2O3 to moles of Fe to weight of again iron. Correct? Another type of problems. mass and volume relation. See, in this problem, for complete combustion of ethane, the required volume of oxygen and produced volume of carbon dioxide as T will be. So they are just asking what is the, see, you have 3 gram, convert it into volume, okay. So the mole is 0.1, so first convert it into moles. Again, you have 3 gram, you know the reaction, 2, 7, 4, 6 are the ratio of these compounds. So convert this 3 gram, you have to convert 3 gram into number of moles. So now you know 0.1 mole of this is reacting. So it means 2/4 is the ratio, it means 1:2 is the ratio, right? So it means for one combustion of this mole, you will get, if it is 0.1, you will get 0.2, understandable? If it is 2:6, it means 1:3, it means if it is reacting 0.1, you will get 0.3, understandable? You have to know the ratio, so you will get 0.35 mole of the required O2, okay, and for oxygen, now you have the mole, you can multiply by 22.4 to get the volume. Same way for carbon dioxide, you can get 0.2 mole and then just multiply by 22.4 to get the exact volume, okay. That is it. Another type of problem. Okay, I think it's again same. In the following reaction, if 10 gram of hydrogen reacts with N2, what will the volume of ammonia formed? 10 gram reacts with N2, 10 gram of H2 reacts with N2. So see, first of all you have to convert this 10 gram into moles. You cannot, once there is a stoichiometry, always convert into moles or volumes, then only discuss something, okay. So whatever the volume, see this is 10 gram, the mole is 5 moles. So 5 mole of this is reacting, then how many moles of N2 is required? You have to take the ratio, 1:3, sorry, ammonia is formed, na? So 2:3 is the ratio, okay. Then 2/3 is equal to 10/5. So you can actually just take the ratio, find the number of ammonia produced, and then you can easily find out the volume by multiplying by 22.4, and that is the answer. Got it? Now the questions are volume relationships, okay. Okay, let's see if you guys are able to do this or not, because see the problems are similar. Okay, Kanishka, please give us some time, sir. We will be solving. Oh, sorry. Okay, try to solve, guys. Sorry. Try to solve. You start solving this question. Priya Jyoti, sorry. Try to solve this question. Kanishka, you also try. Kanishka, try to solve question. Priya, Shraddha, Aira, you guys also try to solve questions. Actually, I went over with Fe2O3 because you might not know the combustion reaction for Fe2O3. That's why I just skipped it. Because you might not know, then giving time, it's like. Okay. Priya Jyoti, try to answer. Okay, so if somebody who has not answered, I am going to tell the answer now. Let me just check if somebody has answered. Let's see. Okay, nobody has answered right now. Anyways, let's go for the solution. If somebody answers, I'll just take their name. For complete combustion of this much liter of butane, the produced volume of water and carbon dioxide as STP will be. What I will do, I'll convert this 1.12 liter, okay, into the, what do you call it? Okay, this is already in liters, okay. You should convert it into liters or moles. Now it is already in liters, no need to convert anything. That's it. So 1 mole of butane takes 13/2 moles of oxygen to form 4 moles of carbon dioxide and 5 moles of hydrogen. Okay, so 1 will form 4, 1 will form 5. It means 1.12 liter will give 4 times of 1.12 liters of carbon dioxide, and 1.12 liter will give 5 times of water. Okay, okay, somebody has answered. Priya Jyoti, 4.48 liters of carbon dioxide. Very good for 4.48. Very good. Kanishka, 4.48 liters of carbon dioxide. Very good. You guys are right. Try to find out for the water also. It has asked water also. Okay, remember it has asked water. Okay, very good. Now there is a concept of limiting reagent. See, I'll tell you one concept, simple. If you have 1 liter of one reactant which needs 3 liter of the other, okay, so 1 liter will react with 3 liters. Now what if in the reaction you have 1 liter of this and 4 liter of this? What will happen? This 1 liter will react with the 3 liters, okay. So after reacting they will convert into product. So 1 liter of this particular reactant will be left, okay. So which one is the limiting reagent? This is the limiting reagent, okay, because this is not able to react fully, but this is left. So whatever is fully utilized is the limiting reagent. That thing is limiting the reaction. Other thing is left. It is not able to react much. Okay, that is called limiting reagent. Let me guys check if somebody has answered. Okay, now again. So the reactor which is completely consumed in a reaction is called limiting reagent because it is limiting the reaction. Okay, it is not able to let the reaction go fully. For an example, okay, so this is some example given. So A is required 1 mole, B is required 2 moles, which forms C 1 mole and D 2 moles. Suppose this. Now if you have 3 moles of A and 9 moles of B, but just for reacting with B it needs double, it means it only needs 6 moles of B. So 3 will react fully to get 0 mole. Among 9 moles 6 will only react, so 3 will be left, okay, and this will form as simple ratios. Got it? 3 mole form, 3 mole form, 3 mole form, 2 is the ratio, so 6 mole form. Got it? So it means at last reaction B is left 3 mole, C 3 mole and D 6 mole. Understandable? So limiting reaction is limiting reagent is which one? This is the limiting reagent. A is trying to limit the reaction, okay, because it is completely consumed. See, if we would have 1 more mole of A, then this B would have reacted. It means this is the compound which is limiting the thing. Got it? That is why it is known as limiting reagent. Okay. Okay. So X, what is this X they are trying to give? I don't know what is this. Okay, leave it. Reactants having least value of X are limiting reagents. Okay, so see. Oh, this is a way to find out. Although you can see after reaction which one thing is left, but you can actually find out which one is limiting reagent by this ratio. Okay. Where's my pen? Yeah. So you can find out which one is a limiting reagent, which reagent is going to be consumed properly, fully, by utilizing this ratio. So whatever the given value is, if it is in terms of liter, whatever it is, you divide with the stoichiometric coefficient. Got it? So it was 3, so you divide by 3 by 1. Got it? It was 2, so see, given is what? Given is 9, but divide by 2. Okay, this is 4.5, this is 3. Which one is lesser? Sir, 3 is lesser. It means it is the limiting reagent. Okay, reactants having the least value of X are the limiting reagents. That's it. Okay. Oh, I don't want to save this. Okay. Now see, 3 by 1 is 3 and 2 by 9 by 2 is 4.5. This thing is lesser, so this is the limiting reagent. That's it. That's how you find the limiting reagent. This is a way to find out. By the way, you can easily observe this. You don't need this formula. I think I never use this formula. Okay. Somebody has something answered or not? Okay, nothing. I think there will be some questions ahead. Let's see. Okay, wait, I'll not give you the answer. So illustration 5 is there. Hydrogen is reacting with half moles of oxygen to form water. In the above reaction, what is the volume of water vapor at STP? Okay, you are given with 4 gram of hydrogen and 32 gram of oxygen. I think it is visible, right? Let me check. 4 gram of hydrogen and 32 gram of oxygen. So you have to find in the above reaction what is the volume of water at STP. You have to find the volume of water at STP. These are the reactants which are given. 4 gram of this, 32 gram of this. Find amount of water molecule. Tell me guys, let's put some timer. Kanishka, Jyoti and if Shraddha is there, try to do this problem guys. Try to do the problem, guys. 42 seconds. I'll give extra 20 seconds for this because sometimes there is a lag, okay? Because 52 and here 33, it means 20 seconds of lag is there. I'll have some water. Same way I will do a one shot for atomic structure, and after this thing I will give you 50 questions, okay, in DB form, and I'll upload the lectures, 25 questions for the next day and 25 questions for another next day, okay. So if you have watched this, you cleared your concept, then you should watch other 2 videos to attempt questions, okay. So you will have a good amount of questions before you go to an exam, okay. Okay, now let's start. I'll check if somebody has answered. First of all, this is in mass. Mass doesn't work in stoichiometry. Okay, let's see if somebody has answered. Where's my pen? Okay, wait. Priya Jyoti, Kanishka not answered yet. Okay, anyways, I will do it. I think you guys are still solving, and maybe there's a 20-second lag. See, 4 grams of hydrogen is there. It means how much moles? Tell me. 4 grams of hydrogen is there, right? It means how many number of moles? So 4 by 2, it means 2 moles, okay, of hydrogen. So 32 grams of oxygen, it means what? So 32 grams by 32, it means given mass upon molar mass, so it means 1 mole of oxygen. But for the reaction, 1 mole of hydrogen requires half mole of oxygen to form 1 mole of water. You have 2 moles of this, okay, and you have 1 mole of this. So you will form 1. See, this is the least thing, half, double. Can you see which one is the one? 2 by 1 and also 1 by 1. Which one is the least? So it means you have to find out limiting reagent. So let's see. Most moles of water is what? 2 mole. Okay, V by 22.4. Now see. Wait, I think there is no limiting reagent in this one. Got it? See, the ratio is 1 and half. It means 2:1. The compound is also formed in 2:1. That's it. So it means if it is found 1 from this one, then from this 2 amount of water will be formed. Okay, 2 moles of water will be formed. 4H2, 4O2. Okay. Okay, this is limiting reagent reaction they have written over here. Okay, so 2 by 1 given moles upon the stoichiometric ratio, given moles upon stoichiometric ratio. Okay, so they are equal. It means no limiting reagent is there. Got it? Somebody has answered something? Sir, I have answered it first. Priya Jyoti 44.8 liter. Oh, sorry, you guys have answered the previous question. I thought it is just the repeating one. Okay, Priya Jyoti, very good, very good. 44.8 liter you have answered. I thought you answered the previous question. I thought you are answering the previous question. Now, 44.8 liter, very good, Priya Jyoti, and another one is, I think Kanishka is there. First. Yeah, Kanishka, second. Very good. Now you have, but now you know 1 mole of hydrogen, 1 mole of water, 2 mole of hydrogen, 2 mole of water. 2 mole of water is 22.4 into 2, that is 44.8 liter. That's it. 1 mole 22.4, 2 mole 44.8. That's it. Got it? Now let's cut it out. Okay. We are going till the end of the session. Okay. Again, guys, do this problem. At NTP in a container, 100 milliliter of N2 and 100 milliliter of hydrogen is there, are mixed together. Then find out produced volume of ammonia. So now see, 100 of nitrogen and 100 of hydrogen. Got it? So find out produced volume of ammonia. Now this is a question of limiting reagent. Guys, do it. Priya Jyoti, Kanishka, guys, try to do this question. Because see, N2 and H2 are in the ratio of 1:3. Okay, so for 1 mole of nitrogen, 3 moles of hydrogen will be required. 1 liter of nitrogen, 3 moles of hydrogen will be required. So 100 milliliter of nitrogen requires 300 milliliter, but 300 milliliter is not present. Okay, got it? So this is the limiting reagent, limiting the reaction, not letting the reaction fully complete. Okay guys, try to do it. Okay, somebody is on the Priya Jyoti. Ammonia is 67 milliliter. No, 67, I don't think it will be the answer, but let me check. Okay, 67. I think ammonia is formed twice. No. Okay, it is twice, naha. Then 67 is the answer. Let me check. Yes, 67 or 66.6. Okay, simple. I'll tell you one simple case. 1:3 is the ratio with which they are reacting. Okay, 1:3 is the ratio with which they are reacting. If 100 milliliter of N2 is there, it needs 300 milliliter of hydrogen, so they can't react fully. Okay, got it? Or you can divide the 100 milliliter by stoichiometric coefficient, 100 liter by milliliter by stoichiometric coefficient. It means this is this number which is lesser. It means this is the limiting reagent. Okay, now this thing is going to be fully consumed. Got it? Now in this reaction, hydrogen is limiting reagent, so reaction will proceed according to hydrogen. Okay, now see, 3:1. 3 milliliter of this requires 1 milliliter of this. 100 milliliter of this will require 100 by 3. That is what I meant when they say the reaction will proceed according to hydrogen. Got it? Okay, so 100 by 3. 100 by 3 nitrogen, that is 1, it forms 2 ammonia. It means 100 by 3 will form 2 times of 100 by 3. 2 times of 100 by 3. Now that is 66.6 milliliter, or you can read the further definitions also. Understandable? That's it. Okay. Now there is a concept of equivalent weight, okay, which we need to study. Where is my cursor? Okay. I have to cancel this, then I will be able to see my cursor. Okay, matters for calculation. Okay, we'll have done equivalent weight. Now here we have a concept of equivalent weight. What's the time? Okay, the session is going 2 hours. Anyways, just just be with us, okay? Because it will take just 30 minutes more, not much, I guess, right? Now let's understand what is equivalent weight. The equivalent weight of a substance is the number of parts by the mass of substance that combine with or displace directly, indirectly. This much part of hydrogen, this much part of oxygen, this much part of chlorine, this much. Okay, leave it. I'll tell you. Okay, equivalent mass. It tells you how much amount of the substance it is going to displace from the other one. Got it? Okay. Equivalent weight tells you how much weight of a hydrogen by part it is going to displace from the other. Okay. It means it will tell you how much amount will be replaced by 1.008 parts of hydrogen, or 8 parts by mass, or 35.5 parts by chlorine. But even if you didn't understand this particular definition or whatever it is, okay, no worries, because no need to use this. You just need to understand equivalent weight is whatever the atomic weight, you have to divide by the valency factor. What is the valency factor? N. Okay, N is a number. Got it? And equivalent weight of ions is equal to formula weight of ion divided by valency factor. What is this? N again. Got it? Whatever you have, weight, anything, okay, you have to divide by N factor. Now this N factor depends upon various conditions. In case of ions, they have not given it correctly, right? No, they have given it correctly, but it's not a good manner. Okay, remember, let me teach you this. What is equivalent weight? Tell me. Sir, equivalent weight is given mass, sorry, not given mass, whatever the molecular mass is divided by N factor. Okay, that's it. This is the equivalent mass. Okay, equivalent mass is molecular mass divided by N factor. Now this molecular mass is different for different types of compounds. If you talk about normal compounds, okay, wait, if you talk about ions, okay, N is the balancing charge, okay, the charge which is getting balanced. So for an example, NaCl, whatever the molecular mass of NaCl divided by the charge. So what is the charge that is getting balanced? Plus and minus. So it means check the magnitude, plus 1 minus 1, the magnitude is 1. Okay, so this is the thing. Got it? Now in case of acid, okay, it is the number of hydrogen ions which are displaced, number of H positive ions which are displaced, that is the value of N. Got it? Okay, number of hydrogen ions which are displaced, that is the value of N. For an example, in HCl, whatever the molecular mass is divided by the hydrogen ions that can be displaced, that is 1. In case of H2SO4, now H2SO4 has 2 equivalent mass. If you remove only one hydrogen, then this is the molecule equivalent mass. But if you remove both hydrogens, then this is the equivalent mass. Got it? The another thing is same way for basicity. Okay, base. For base, it is the amount of OH negative ions which can be displaced, and that will give you the value of N. Okay, for an example, in NaOH, only one OH can be displaced, so the value of N is equal to 1. In case of other compounds, like other in which can't remember them right now. Okay, NOH, but you talk KOH, NaOH. So what are number of hydroxide ions? 1. So that is the value of 1. Got it? Cis-military ammonia. Got it? Okay. So these are the only things for the equivalent weight. Got it? Equivalent weight of acid or base is acidity or basicity. That is the same thing as hydrogen ions and OH negative ions. Got it? For acid it is called the basicity. For base it is called the acidity. Okay. In case of salt, total charge on cation or anion. NaCl, Na positive plus 1, Cl negative means minus 1. It means still 1. Got it? So for an example, in case of N2SO4 salt, 2 Na positive and SO4 2 negative. What is the amount of charge getting balanced? See, 2 negative, 2 into plus 1, it is 2 positive. So the total charge on cation and anion is 2. It means whatever the molecular weight is divided by 2, you will get the equivalent weight. Understandable? In case of oxidizing or reducing agent, you will not get what is oxidizing or reducing agent right now, but once you study electrochemistry, okay, and redox reactions, you will understand it. Okay, to find out them, molecular weight of the substance divided by number of electrons which is gained or lost by one molecule per molecule. Okay, you might not understand this at right now, but those who have studied electrochemistry or redox reaction will understand this. Okay, concept of gram equivalent and law of chemical equivalence. Simple. What was gram molecular mass? Sir, it is whatever the given mass divided by molecular mass. Same way, gram equivalent mass is given mass divided by equivalent mass. That's it. Okay. So given mass upon equivalent mass. Okay. And equivalent mass is valency factor by m. Right. Now, according to it, in a reaction, equal number of gram equivalents of each reactants react to equal number of gram equivalents of products. Now, why are we studying this gram equivalent? Remember, in any reaction, 1 gram equivalent of this reaction reacts with other 1 gram equivalent to form 1 gram equivalent and 1 gram equivalent of all the compounds. Try to understand this. Number of moles are different. N2 reacts with 3 hydrogen to form 2 ammonia moles. But the gram equivalents are going to be same, right? And this is what it is being said, and that is the reason we are studying this. In a reaction, equal number of gram equivalents, okay, gram moles of reactants react to equal number of gram equivalents of products. Got it? So, number of gram equivalent of A, B, C and D all are going to be equal, but number of moles are going to be different. Understandable? That is the importance of gram equivalent. Are you able to understand this? Kanishka, Priya, Jyoti, are you able to understand this? Whoever is watching, tell me guys if you are able to understand what is gram equivalent, because this is just a tricky concept. Okay, this is the importance. 1 gram equivalent of this reacts with 1 gram equivalent of this to form 1 gram equivalent of this and 1 gram equivalent of this. But moles may not be same. A number of moles react with B number of moles to form C number of moles and D number of moles. Moles are different. Gram equivalent is going to be same. That is the reason we are studying this. Remember. Got it? Now, so how can we calculate atomic weight and molecular weight, there are two methods. First, molecular weight is 2 times of vapor density. You can easily calculate by this method. Another method, vector mass method, is used to determine molecular weight of volatile compound. Okay, this is it. You can just remove it. Okay, now this is an experimental way of just determining the molecular weight. Okay, let's revise some golden key points. Okay, the golden key points are equivalent weight of a specific species changes with the reaction in which it is gets involved. Okay, now equivalent weight of a species changes with the reactions. So H2SO4, okay, in some case it will give only one H positive, right? Yes or no? In some cases it will give both hydrogen ions. Got it? So the number of H positives are different, the value of N is going to be different, so it means the equivalent mass is going to be different. Got it? So that is why it is said equivalent weight of species changes in with the reaction in which it is getting involved. Understandable? Equivalent weight getting changed in which the reaction it is getting involved. Now, amount of substance which loses or gains 1 mole of electrons or this much of coulomb of electricity will always be its equivalent weight. Okay. This particular definition is for the person who have studied electrochemistry. If you would have studied electrochemistry, you would have known this thing. Okay, don't worry. Now, there are some laws of chemical combination, and after this we are finished. Okay, literally, if you guys are bearing with us, okay, bearing with me, not us. Okay, now you can easily understand this. Only these things are left. So you guys know what is the law of mass conservation? The mass of the reactant is equal to the mass of the product. One of the most simple reaction. That's it. Nothing else. Okay. Law of definite proportions or law of constant composition. It means what? See, if you find water from your pond, if you find water molecules from your filter, if you find water molecules from somewhere else, okay, all of these water molecules, the hydrogen and the oxygen ratio in all of these molecules are going to be present in the same ratio. Understandable? Sorry, same ratio they are going to be present. Understandable? 2:1, 2:1, 2:1. Doesn't matter which water molecule you will take. So the proportional is definite. That is called the law of definite proportions. Okay. Avogadro's law again, 22.4 liter is equal to 1 mole. That's it. Okay. Law of gaseous volume. It tells you that at same conditions of temperature and pressure, same conditions. Just take for an example STP or NTP. It is not necessary, but for an example, if you take same condition of temperature and pressure, all kinds of compounds or gases, okay, with equal volumes will have equal number of particles. Okay, equal volume, equal number of particles. Doesn't matter which compound, which element, which atom. Got it? If it's equal volume, equal gas. Only if both of these gases you are talking about should be at similar conditions of temperature and pressure. That is law of gaseous volume. Understand? And it is a little bit tricky, not tricky, I'll say just a little hard to understand law of multiple proportion. Okay. So see, if I say law of multiple proportion. Now, if there is I'll try to make you understand this thing. First of all, wait. Okay, I hope there is no confusion at all. Law of multiple proportion. Now, how do you do this? If you have carbon, oxygen, okay, carbon, oxygen and water. Okay, see this. Okay, wait, I'll change this thing. So, carbon, hydrogen and oxygen. What is the compound formed by hydrogen or water? H2O, maybe, let it be H2O. Okay, carbon and hydrogen, CH4. Okay. Now, what is the ratio of oxygen and hydrogen in here? Tell me. Ratio by mass and ratio of carbon and hydrogen by mass. Tell me. Sir, this is 12 and this is 1. Tell me. Wait, how can I tell you? Okay. See, the hydrogen and oxygen. What is the ratio of hydrogen and oxygen? Tell me. Hydrogen is sir 2 and oxygen is sir 16. It means 1:8, right? So 8 particle of this thing, 1 unit of this thing. Got it? Now again, same thing. Try to do this. For carbon and hydrogen, sir, carbon is 12, hydrogen is 4. So what is the ratio? Sir, carbon is 12 and hydrogen is 4. So ratio is 3:1. It means, sir, ratio is 3:1, right? Now, form a compound between carbon and oxygen. Take the compound to be carbon dioxide, right? This is a compound which is formed, okay? Now, if you take this compound, carbon dioxide, what is the mass of carbon? Sir, mass of carbon is, sir, 12 and mass of oxygen is, sir, 16 to 32, right? That is the mass, okay? I hope I am taken this way. Now, let's cancel this out. So, we'll get 4 3 is 12, 4 is 32, okay? 3:8. So, 3 ratio of the carbon and 8 ratio of the oxygen. Now, this is the time to study about the definition of the multiple proportion. The amount of mass of one thing, okay, which is reacting, the same amount. See, the amount of carbon and oxygen, okay, reacting with hydrogen, or say same amount of hydrogen. If carbon or oxygen, two compounds are reacting with one compound, okay, equal mass of that one compound, then if these two masses, if these two compounds are going to react with each other, they are going to react with the ratio. Got it? Understandable? This ratio. Yes or no? This is the law of multiple proportions. Okay? If you try to compare this example, okay, compare this example with the internet definition of law of multiple proportion, then you will surely get it crystal clear. Okay? I hope it is understandable. Now, okay, so we are finished. Yes, we are finished. Okay. Now we are finished for today, right? So we are finished for the day. We have done all the concepts of some basic concepts of chemistry, and in the next 2 days we are going to do 50 problems, okay? In the first session 25, in another session 25, okay? This session is already full of some illustration and all those things, but these illustrations and the examples were very easy, okay? In the next session we are going to do much, okay? Okay, thank you Priya Jyoti, thank you. So now you guys can leave the session, okay? And I think that is it. We are going to produce 2 live sessions more, 125 questions and again 25 questions, okay? 25 and 25 for 2 live sessions. And then we will wrap up this chapter and continue the one-shot series of another chapters like atomic structure and all those chapters. Got it? Till then, see ya, bye-bye. If you have bearing till now, okay, it's good. Keep hustling. Bye. Have a nice day, guys. Kanishka, thank you Priya.